A large model Showman'S engine, and this is part 10, matching the paint colour and making a regulator extension. I don't need to match the red colour, which is Crimson Lake, at all, because Phoenix Precision Paint's Crimson Lake that I'm using is exactly the same colour as what's on the engine. But this is not so with the yellow wheels. Initially I used a small tin of Humbrol enamel, number 69 gloss yellow, and mixed in a very small quantity of Great Northern Railway green, once again from Phoenix Precision Paints. And then on the shelf in the outer part of the workshop I found this tin of BR Signal Yellow. The BR is an abbreviation for British Railways. I found that to accurately match the existing paint I needed to use 4 stickfuls of the GNR Loco Green. I know that's not very technical and it's the best I can do really. How do you mix a colour to match another colour? Well, you have to use your eyes, that's all you can do. By the term 4 stickfuls, it means I put a stick into the green paint, then stir it into the yellow paint, clean the stick and repeat the process another 3 times. Matching this colour was quite easy. It's black, although there are different shades of black. The original Smokebox paint was marked in places, so I rubbed down the damaged area of the paint using some 400 grit wet to dry sandpaper, which I used wet so it cut better. And here I am brush painting the entire Smokebox, including the part that holds the generator, using some HMG satin black paint. This is normally in an aerosol, but I sprayed a quantity of this paint from the aerosol into the plastic cap. I've already given the part underneath the generator a first coat, and you can see how well it looks once it's dried. What I propose to do after this coat is let it fully harden by leaving it for a few days, then give the entire area a rub down with some wet to dry sandpaper, and after that the final coat should do the trick. The next job on the list is to make an extension handle for the regulator. For 2 reasons. When I sit behind the engine, the regulator is just too far away, and when the boiler's at full working pressure, the regulator handle is quite short and very difficult to move. A few months ago when I was in Blackgates Engineering, Matt gave me a piece of tubing, and he said he didn't know what it was it phosphor bronze, was it copper? Anyway, it's copper. And this piece of thick-walled copper tubing fits perfectly over the existing regulator handle. And also because copper is a soft metal, it's not going to mark the original regulator handle. Perfect for the job. All I need to do is make a fitting for the top of it. So it's over to the lathe and I have a piece of leaded bronze in the chuck. This stuff is like phosphor bronze, but it's easier to machine. I'm turning down part of this piece of bar to be a nice push fit in the piece of copper tubing. This leaded bronze machines beautifully. The red phosphor bronze is really horrible. It doesn't machine well at all and gets extremely hot. This is going to become a very important part of the regulator extension. Brass is no good because it's a bit on the weak side and it will wear badly. The last thing I want is a really loose, rattly extension to the regulator. Once I turn down the end part to fit in the tube, I just reduce the diameter of the outer part slightly. And once I've done that, I parted it off. I speeded up the video for this bit. I don't normally part off at this speed. Once the part fell into the chip tray, I retrieved it and fitted it into the chuck the other way around. Then I reduced the diameter of this end part of the way down. I didn't turn it down as much as the other end that fits in the copper tube though. This part needs to be fitted into the milling machine so I can mill down each side to make it flat. I didn't take any measurements or use any measurements whilst I did this. I just turned it down to a size that looked right. Here I'm rounding the end. You'll see why very shortly. Now it's time to go over to the milling machine and I'm using my rotary table. I don't really need to use a rotary table for this job. It's just very convenient to clamp the part in the chuck. Here I'm tightening the 2 clamps that stop the chuck from moving. Now all I need to do is mill down each side of this piece of phosphor bronze. As you can clearly see in this clip, there are no refinements on my old milling machine. I have to wind the handle. There's nothing wrong really with turning the handle by hand, but I'm always resisting the urge to turn the handle too fast and speed up the job. The milling cutter fitted to the R8 collet is an end mill. Using an end mill instead of a slot drill is a good idea. There are more cutting surfaces on an end mill rather than the 2 that you find on slot drills. The clue is in the name. Slot drills are really useful if you're cutting slots. Some viewers may be thinking, how do I know how much to take off each side? Now, I could go into great detail about using the graduations on the slides, but this is a very simple part. It doesn't have to be that accurate. Like I say frequently, this is not a part for a gas turbine or a space rocket. I'm using my calibrated eye. And how do you get a calibrated eye? Not from Amazon and not from eBay. You calibrate your own eye just by practicing and doing the job. And at first you will make a real mess of the jobs that you're doing. But don't worry about that, keep trying, and then, pardon the pun, you will see the light. The light coming into your calibrated eye, being reflected perfectly back from the object that you're making. For the final cuts, I increase the depth of the cutter, and now it's milling the bottom part as well. After the milling operation, it's now back to the lathe. I refitted the part in the 3-jaw chuck, and I'm taking a very fine longitudinal cut right down to where the milled part meets the round bit. I'm really sorry for all these technical terms. If you're a beginner, they must be very baffling. The round bit that I refer to is the part that hasn't been milled flat. By taking a very fine cut along the edge that's been milled and removing a very small amount from the round part, the entire component looks better. In this part of the clip, I'm shortening the component because it's a little bit long at the end. I'm also re-rounding the edge as well. After drilling and reaming a 1/4 inch diameter hole through the centre and then cleaning up the edge of it on the belt sander, it looks like this. All I have to do now is press it into the copper tube. I'm going to use some Loctite 603 to make sure it never comes out of there. Well, it would come out of there if I heated it up, but I'm not going to do that. Here's the finished component. And that's the first part of the regulator handle extension that I've made. I'm waiting for a long piece of stainless steel to arrive from Blackgates Engineering, then I will continue. But in the meantime, I think I'll make the handle and the bracket. But that's it for now. Stay safe, stay well. Thanks for watching, and I hope you found it useful. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.